Hey folks, how we doing? Mr. Carter here, ready to do math lesson 7.3 today. Fraction as a multiple of a unit fraction. So here we go. All right, so our target today is this. I understand how to represent fractions as multiples of a unit fraction. All right, so here's our math message. Let me just slide this over here. So Jen needs 1/3 cup of skim milk to make a strawberry smoothie. Now choose a fraction circle piece to represent how much milk Jen used. If the piece you chose represents 1/3, what piece is the whole? Okay, so here's the math message again, but what does this mean? Like, I don't understand what they're saying. So let me explain. Well, if our whole, for example, was a red circle, then 1/3 of that whole would be one orange. As you can see here, you have 1/3, 1/3, and 1/3. So that's the pretty basic, how to represent a fraction using the red circle. But let's say our whole in this case would be a pink, right? So if we're saying, let me just get this out of my so let's just say our whole was half, or not half, sorry, the whole was a pink. Well, then our thirds would be a light blue, as you can see here, because 1/3, 1/3, and 1/3, because 3 light blues make that pink. Let's say our whole was the yellow, right? So then we have to take that yellow, split that into thirds, and that would be a light green. So 3 light greens equals that yellow. And as you can see, it's 1/3, 1/3, and 1/3 again. Our whole may be, who knows, it could be 6 purples, right? So let's say our wholes was 6 purples. Well, if we put some fraction circles on top of that, the dark green would be a third. So 1/3 here, 1/3 here, 1/3 here. So that's basically what the math message is asking you. To start thinking about that 1/3. All right, so remember this? Okay, I'll remember. What? Anyway, so unit fractions. So this was taught a few units ago. So a unit fraction are a fraction with a 1 in the numerator. So for example, 1/3, as we were just talking about in the math message, is a unit fraction because it has a 1 in the numerator. That number on the top of the fraction is a 1. Any fraction with a 1 on top is a unit fraction. It could be 1 out of 10. It could be 1 out of 100, 1 out of 227. It doesn't matter. As long as there's a 1 on the top of the fraction, it is a unit fraction. So we're going to need to know that for today's lesson. So in this lesson today, you will learn that any fraction can be represented as a product, so we know we're multiplying, of a whole number and a unit fraction. So in other words, any whole number A, let me take that back. Any fraction A over B equals A as a whole number times a unit fraction over B, right? So 1 over B. So again, let me repeat. So any fraction that is A over B equals A. So that number and this number will be the same as we get going, and times a unit fraction. So if this works, prove it now. All right, so I will prove this now. All right, so let's look back at the math message. But this time we're going to talk about more than one smoothie. So it says here, Jen needs 1/3 cup skim milk to make a strawberry smoothie, same as the math message. But this time, how much milk would she need for 2 smoothies? So the answer there is 2/3 cup. Like, you can do that one in your head. But let's break it down. How can you represent the number story with fraction circles? Well, 2/3. If your red was a whole, you would have 2 oranges as your 2/3 cup. 1/3 and 1/3. That's again if your whole was the red circle. How can you represent this particular problem with an addition equation? And that's probably what you did in your head. You said, okay, she needs 1/3 cup of skim milk to make a smoothie. And if she needs 2 smoothies, so then you would go 1/3 plus 1/3 equals 2/3. How can you represent this problem with a multiplication equation? Well, again, if there were 2 smoothies, and each smoothie required 1/3 cup of milk, you would go 2 smoothies times 1/3 cup of milk to get your 2/3 cup of milk. All of these, my friends, represent the same amount. No matter if you're looking at the fraction circles, as we did above, or the addition problem, you got 2/3, or the multiplication problem. They all got the same amount, which is that 2/3 cup of milk that she's going to need to make 2 smoothies. All right, remember this? Okay, I remember what? A multiple is a product of that number and a counting number. Multiples, again, are when you can count by that number. So let's take a look at the same problem, but this time we're going to just keep adding smoothies. So again, Jen needs 1/3 cup of skim milk to make a strawberry smoothie. How much milk would she need for 3 smoothies, 4 smoothies, 5 smoothies, 6 smoothies, etc.? So again, so she was doing 3 smoothies. We know that the multiplication equation for that would be 3 smoothies times 1/3 cup milk for each smoothie would equal 3/3. 4 smoothies, again, if we were looking at it as a multiplication problem, we would go 4 smoothies times 1/3 cup, and that would equal 4/3 cup. 5 smoothies, 5 times 1/3 cup again would be 5/3 cup. 6 smoothies, 6 times 1/3 equals 6/3. So now let's talk about multiples, which we were talking about. And again, if you're counting by, this time we're counting by thirds. So 3/3 is the third multiple of 1/3, right? So 3/3 is the third multiple of 1/3. Because if we're counting by 1/3, we'd go 1/3, 2/3, 3/3, and we're counting by thirds 3 times, right? Same thing with 4/3. But 4/3 is the fourth multiple of 1/3. 5/3 is the fifth multiple of 1/3. 6/3 is the sixth multiple of 1/3. We starting to see a pattern? All right. So again, 3 smoothies, same multiplication problem. 3 times 1/3 is 3/3. So we're just going to go through 4 smoothies, 5 smoothies, 6 smoothies. So I'm just putting back the multiplication equations that we had before. So again, your whole number here was 3, right? 3 smoothies. And look at what the number is at the top of your answer. It's also 3. 4. And the number in your numerator in the answer is also 4. 5 smoothies. And again, the number on the top, the numerator for your answer is also 5. 6 smoothies. The answer has a 6 in the numerator. So I'm starting to see a pattern here, right? So let's break it down. So remember that equation I showed you at the beginning, right? So A is your whole number. So let's say that's the number of smoothies, for example, times a unit fraction. Yeah, and I didn't talk about that, but all of these thirds are unit fractions, right? Because it has a 1 in the numerator, 1 in the numerator, 1 in the numerator. So when you're taking a whole number times a unit fraction, which has that 1 in the numerator, it's going to equal that whole number in your numerator over, and your denominator just slides over. See, the b is the same as the b over here. So if we're looking back over here at the smoothies, right, it's 1/3. Your denominator stays the same, right? Same thing here. So that is our rule now for multiplying a whole number, which would be your a, by a unit fraction. So every time, again, let's recap. Every time you're multiplying a whole number by a unit fraction, you take that whole number and you put it at the top in your numerator, and you just slide over the denominator. Let's do some more examples. So if we had 3 times 1/4, or 1/4, sorry, again, your whole number is 3 times 1/4. So then your answer is going to take that whole number and put it on the top. So 3 times 1 is 3, and you slide your denominator order over. You don't change your denominators. Denominators stay the same, right? And again, that whole number is in your numerator. So 9 times 1/6 would equal 9/6. And again, your whole number goes on top here, and you slide your denominator. So 9 times 1 is 9, and then you just slide your denominator over. Let's look at this, 5 times 1/2. So again, the answer here is 5/2. So again, that whole number is the answer in your, is the numerator in your answer. All right, so now go to page 234 in your math journal. We're going to do a couple of math problems together. All right, let's look at number 1. Write an addition equation and a multiplication equation to describe each picture. So I'm seeing some fractions here, some fraction circles, and I'm noticing that the fraction circles are split into eighths. 1, 2, 3, 4, 5, 6, 7, 8. Both of these are eighths, and 1/8 is shaded in. So this shows that we need to go 1/8 plus 1/8, and that would equal 2/8. So you have 1/8 plus 2/8 equals 2/8. What's your multiplication here, equation here? Well, if you have two fraction circles and you're multiplying 1/8, you would also get 2/8. So it's 2 times 1/8 equals 2/8. And what the question is, what's the second multiple of 1/8? So if you're counting by 1/8, right? Again, that word multiple means counting by. So we're counting by 1/8, right? So the second multiple of 1/8 would be 2/8. All right, let's look at number 2. So number 2, we have a number line here, right? And it looks like we're counting by fifths, right? So we have 1/5, 2/5, 3/5, 4/5, 5/5, 6/5. So what does that look like as an addition equation? Well, you're adding 1/5 6 times, right? 1/5 all the way down to 6 times to get 6/5. What does that look like as a multiplication equation? Well, if you're counting by 1/5 6 times, that would be 6 times 1/5 to get your 6/5. What's this? That means, again, what's the sixth multiple of 1/5? So if we're counting by 1/5, right, we're counting by 1/5 6 times, the answer there would be, of course, 6/5. All right, so now you have two math journal pages to work on. So work on the rest of this page and also page 235 by yourself, see how you do. If you have questions, you can go see your teacher and see if they can help you. And I hope this was helpful. Take care.